Alright, hello class. We're going to learn today about triangle congruence theorems ASA and AAS. We previously learned last week that to prove two triangles are congruent, all six corresponding parts must be congruent to each other. Then we learned it's possible to prove two triangles are congruent using three sets of corresponding parts, either three sets of corresponding sides, which we called side, 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 or two sets of corresponding sides and the included angle, which we called side, angle, side. There are still other groups of corresponding parts that can help prove two triangles are congruent. First one I'm going to learn today is called angle side angle. It's ASA, congruence theorem. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So just like last time we learned about included angles, this time we're talking about included sides, which would be in the middle of the two angles. So for example, in this picture, say we were talking about this angle here and this angle here. This would be the included side. It's in the middle of those two angles. And that would have to match up with this one and this one and this. So you would say something like, first of all, this would be a different measurement than A. So let me mark that with two arcs. You could say something like angle C is congruent to angle Z, and then you would have the side AC is congruent to the side XZ, and then you would also have the third statement, which would be angle A is congruent to angle X. And then you could write your congruent statement, the whole thing, the whole triangle ABC is congruent to the whole triangle, making sure you match up the corresponding letters. A matches up with X, so triangle X, then we did A to B, so B matches up with Y, so we go to X, Y, and C matches up with Z. Okay, so this is your congruent statement. We're going to have to prove each part, the angle, side, the other angle, like we've done before. Here is an example. BD bisects angle ABC. Here's angle ABC. And also angle ADC. ADC. So this is angle ADC. Okay, if it bisects it, you probably know that creates two equal angles. So this angle right here is now equal with this angle right here. And the same thing down here. This one is now equal to this one. Okay, so let's continue making a two-column proof. Just like we've done before, this is your statement. And here are your reasons. You've got an angle. We got to use three letters to be specific. So we'll say angle ABD is congruent to, it's this one right here, congruent to this blue one, CBD. And this is a definition of angle bisector. Okay, I actually should have written this thing as the first step in saying given. And because we know this is true, then we know that this angle is congruent to that angle, definition of angle bisector. We also know the angle ADB, which is this one right here, is congruent to angle CDB. It's this one right here, the blue one, CDB. Okay? And that once again is definition of angle bisector. So we've done two angles, angle and angle, and we have to do the included side. Okay, so the included side would be this segment in between. So if we got this angle, then we'd have to go with this side and that angle. This is angle, side, angle. Same thing on this side of the triangle, angle, side, angle. So let's do the included side. BD is congruent to BD. Okay, and that is reflexes as we talked about before. Now you can say the whole triangle ABD is congruent to the whole triangle CBD, making sure to match up the letters, and that is angle, side, angle. Okay, we've proven each part. Even though I did out of order, it's fine. You can do them out of order. We did an angle, we did side, we did the angle. Okay, we got the same idea on the next one, except for it's angle, angle, side. Two angles on the non-included side of one triangle are congruent to two angles on the congruent to the corresponding two angles inside of the second triangle, then the triangles are congruent. So for example, this would be something like this. Two angles, this one, and a non-included side. Other than BC, I could have chosen this one too, so I just chose those. So it would be this one match up with the R would match up with C, Q would match up with B, and this would be the non-included side. Okay. Likewise, I could have done uh, two angles and a non-included side, something not BC. I could have done this one. Okay, so we'll use that idea for this proof. Okay. Let me remind you that this little tick mark means that it's congruent to this side. Okay, that's what RQ is congruent to ST. So you could write that down if you want to. RQ is congruent to ST. How do we know that's true? Well, given. Okay, these little triangles are telling you these lines are parallel, so RQ is parallel to ST. That's what it says right here. RQ is parallel. Is parallel to ST. Okay, that's also given when it's marked or it's told to us right here. Okay, so we have used this thing right here is one of our sides. Okay, we're going for angle side. There's one we've taken care of the side. So let's worry about the two angles that are so that this side is non-included. So it'd be this angle and this angle, or it could be this angle and that angle. Okay, so let's start with the easy one. This right here. Angle RUQ is congruent to RUQ is congruent to angle SUT. And those are vertical angles. Okay, sorry about sloppiness again. So we've taken care of one angle. Now the other one, so that this is not included, would be, like I said, it could be this one. And I'm going to match up with this one. If you look at this close enough, you can probably figure this out. It might take you a little while, but let's say, for example, we were going to extend this line. I'm going to make a different color so you can see it. This line right here, and this line right there. So if you extend that, then you'll see that this is the transversal, is what I'm trying to go for. This is the transversal. It's probably not very clear, but if that's a transversal and this is the angle right here and this is the angle, then these are alternate interior angles. Interior of the parallel lines alternate across the transversal, so it's alternate interior angles is why this is congruent. Let's see if I can clear that up just a little bit. So this would be the transversal. Okay, so alternate interior angles. So if we were going to write this out, angle QRU is congruent to angle QRU is this one. Congruent to STU. STU. The reason is alternate interior angles. And so that's our second A. So you got it. Another A. We've done each part, and we can say the whole triangle RUQ is congruent to triangle TUS because of angle, side. Okay? This next one here, I'm going to let you try to work on this. If you can bring this to me in class tomorrow, then I will give you a few extra credit points. Okay? There's actually two different ways you can do it. If you do both of them, I'll give you more extra credit points. So it can be done with angle, side. It can also be done with angle, side, angle. Okay? So if you can do that, I'll give you some extra credit points. Alright? And that's that. So good luck. Let me know if you have any problems. See you tomorrow.